This is Unit 6.8, Basic Anti-Differentiation Rules. This is going to probably be the longest video that I do. I am doing 30 examples on here. So we're going to actually start finding the antiderivatives and the integrals. Remember that derivatives and antiderivatives are reverse operations. So we're basically doing the backwards of the derivative rules we've learned in the previous unit. So for example, if we're trying to find the derivative here, given the function, we know that this is going to be 2x. The derivative of sine is cosine, and the derivative of 3 is 0. So when we think in reverse, we have to think, what is the original function if I know my derivative is 2x? And if you can play around, but you're going to get that the original function is going to be x squared plus c, and that c means really any constant. Because we know, 2x, if we started with x squared, took the derivative to get 2x, and if I took the derivative here, that would be 2x, and I took a derivative of a constant, it'd be 0. So basically, the answer, the original function, is any function in this form, where c can be an infinite number of different constants. So example 1, again, we're just playing around with this, but if I know the derivative is cosine, what would be the original function? And if you remember that the derivative of sine was cosine, so h of x would equal sine of x plus any constant. Part B, if I know my derivative is negative 2, that means my original function must have been negative 2x. And again, we're going to keep adding this plus c, because again, the derivative of 2x is just 2, and the derivative of a constant is 0. So thinking backwards, what would be my original function if my derivative was 3x squared? And in this case, our function was x cubed plus a constant, because again, when you take the derivative of this, the 3 comes down, multiplies out front, and then we subtract 1, which would give us 3x squared, and the derivative of any constant is 0. So if my derivative is 0, what was my original function? Well, it had to be a constant of some sort. And again, this constant can be anything. It could be pi, e, 4, negative 2. It just represents any constant number. Okay, so what original function gives me a derivative of negative sine? And that would be cosine of x, again, plus c, because the derivative of cosine is negative sine. And then lastly, what would be my original function if the derivative is 4x squared? So I know this has to be an x cubed of some sort. So again, when I multiply this down here, I would subtract a 1, but I'd be left with a 3. So we have to manipulate it and say, oh, this is 4/3. Because again, if I multiply 3 out here, it would cancel out with the denominator, and I'd left with 4x squared. Okay, so here are your basic integration rules. These are things you're going to have to remember. And just recall that they're the backwards, or they're the reverse of the derivatives. So the integral of sine is going to be negative cosine. And what's the reason? Well, the derivative of cosine is negative sine. Multiplied with that negative turns it positive. Right? Those make a positive. The derivative of sine is cosine. So the integral of cosine is sine. E is our favorite because the derivative and the integral are the same. Because if you take the derivative of e, it's back to e. Now these two are going to be the ones we use a lot. So when you're taking an integral of any function to another power, you basically add 1 to the exponent and then divide by the new exponent. And you can do that for any exponent that's not negative 1, because the integral of 1 over u is going to be log. So if it's something to the negative first power, the integral is log. Because again, the derivative of log is 1 over the inside. And again, to show you an example for number 4, if I have x cubed and I want to take the integral, basically you add 1, so that turns into 4, and then you divide by it. So this would be x to the 4th over 4. And again, you can always play backwards. If I take the derivative of this function, 4 comes down, multiplies outside, it cancels, and then you subtract 1. So you'd just be left with x cubed. So here's 2 important tips for integration. Turn all radicals into powers, and then make sure there's nothing in the denominator. Always move it to the numerator. And I will give you a note that this is the conversion from radical to exponents. So when you have a radical, any exponent in here is the numerator, and the root is the denominator. So we're going to try to hammer out a bunch of these examples. Whenever you have an indefinite integral, which means no boundaries, always make sure to add a plus c. Otherwise, it is technically wrong. Number 5. So we're going to take 5. Okay, so we have x to the cube. So we're going to add 1 to the 3 and then divide by it. So this is really going to be 5x to the 4 over 4 plus c. And that is our answer. Part B, the 2/3 kind of stays away. So this is going to be x. We're going to add 1 to the exponent and then divide by the new number of 3. And if we simplify that, that's going to be 2x cubed. And then down on the bottom is going to be 3 times 3, which is 9, plus a constant. And then sometimes you'll see this written out front like this, because technically that's better. Next one, so this can be pulled outside. So we're going to take 5, we're going to add 1 to it, and then divide it by that same number. Now on top, we're going to get 4x to the 6th, I mean numerator. That's what I mean on top. And then on bottom, we're going to get 6 times 3, which is 18. And then again, plus c. And then if we simplify that, that's going to be 2 over 19 x to the 6 plus c. Oh, what did I say 19? That is 2/9. Okay, so notice how there is no variable x. So in this case, we have x to the 0 because x to the 0 is 1, and then 1 times 3 is 3. And that's just going to give us 3x plus c. And again, if you think, if I take the derivative of 3x, the x disappears and I'm left with 3. And if I take the derivative of a constant, it's 0. So this is just going to be 3 plus 0, which gets me back to my original. Okay, so there is nothing here. So again, we're going to do 1 times y to the 0. And again, we're in the variable y because it says so here. So this is going to be y to the 0 plus 1 over 1, which is just equal to y. Always add a constant at the very end. Okay, so just like when we take a derivative and you can apply the derivative to each variable, I'm not going to write this too many times, but basically you can just take the integral of each part, and each of those have a dx with them. I just didn't write it. So let's take this first part. This is going to be x to the 4 over 4. I'm not writing 3 plus 1. I guess I'll just finish it for this example. So x to the 3 plus 1 over 3 plus 1. Subtract 4. So that's already an x to the first. So we're going to add 1 to that and then divide by it. Plus, and then remember there is an x to the 0 here that we don't see because x to the 0 is just 1. So this will be 0 plus 1 over 1. Always add your constant at the end. And so let's simplify. This is going to give me 1/4 x to the 4th minus, this will be 4 divided by 2, which is 2, x squared, plus, this is just x plus c. So there is my integral. Okay, so we're going to get into some of the more advanced techniques. So remember that it's always best to write these as a power. So I'm going to rewrite this as 5 times x to the 1/2. You can always take the 5 outside. So from here, we're going to add 1 to 3/2. To 1/2. And that gives us 3/2. So this is going to be x to the 3/2 divided by 3/2 plus c. Now, when I distribute this 5 through, and I distribute it here, this 5 is just going to be multiplied by the constant. So we just kind of say that it's c still, because that's any constant. Now, simplifying this, I'm going to get 5 on top, and then I'm going to move this outside and reciprocate. So this is going to be 2/3 times 5 times x to the 3/2. And so if I finish this, this is going to be 5 times 2, which is 10 over 3, x to the 3/2 plus c. And again, when I take this 5 times my constant, I just get a constant. So that's why we just leave it as c. We don't write it as 5c. Part B, same thing. So we're going to write this as a radical. So my exponent is a 1 and a 3. So this can be rewritten as 2 times the integral. Again, I just move my 2 outside. X to the 1/3 dx. And so I'm going to add 1 to 1/3, which gives me 4/3, and then divide by that same 4/3. So I'm going to move this outside. When I take this fraction out, I reciprocate it. It's going to be 2 times 3/4 times x to the 4/3 plus c. And again, just to remind you, the plus c should be in here, but when you multiply it times 2, it's still just a constant. And again, this represents any constant. Now simplifying, we have 2 times 3 on the numerator over 4, which simplifies to 3/2. So that we have 3/2 x to the 4/3 plus c. Okay, again, so this, I'm going to move the 2/5 outside of the integral. And I'm going to rewrite this 1 as 1/4. So again, we're going to take 1/4 plus 1. We're going to add 1 to the exponent, and that gives me 5/4. And then we divide by that same number. Always add your c to the outside. So we're going to change this to a multiply, and then reciprocate. So we have 2/5 times 4/5 times x to the 5/4 plus c. And then if I simplify all of this, I'm going to get 8 over 25, x to the 5/4 plus my constant. Okay, the next type is when you have denominators. And remember, we don't like denominators. We don't really have quotient rules and product rules for integrals like we do with derivatives. So we want to write this as a negative exponent. And the same rules apply. We're going to add 1 to the exponent and then divide by that exponent also. So this is going to give me x to the negative 2 over negative 2, which gives me 1 over negative 2x squared plus a constant. Again, this goes to the denominator to be positive. The negative 2 stays on the bottom, and we always add our plus c at the very, very end. Okay, so I want to pull, just to not confuse us, I want to pull this 2/3 outside. And then I'm going to rewrite this 1 over x squared as x to the negative 2. So let's apply our rules. We're going to add 1 to the negative 2 and divide by that same new exponent. So on the denominator, we're going to get negative 1 times 3. So that's going to be negative 3. 2 is on top. And then since this is negative 1, I'm just going to take it downstairs. And so it's going to be x as a denominator. And then don't forget to add your c. And there is my integral. C. I'm going to pull the negative outside and the 9/5 to make this a little bit easier. And then again, I'm going to rewrite this as a negative exponent. So 1 over x to the 4th is going to be x to the negative 4. So I'm going to add 1 to the exponent, and that gives me x to the negative 3. And then I'm going to divide by negative 3 as well. Now we can do some simplifying while we're here. The negatives cancel. And then the 9 cancels with the 3, and this turns into a 3. So this is going to be, on top, there's only going to be a 1. Oh, sorry, I misspoke, a 3 over 5. And the x is going to go down here to be down to the bottom, to the denominator to be positive. We have x cubed, and then plus c is our constant. Okay, so example 5 is going to kind of combine the root example with the denominator example. So again, I'm going to pull the 2 outside to make this a little easier. And this is going to be 1 over square root of x dx. Now, we do know that that square root of x is going to be a 1/2 exponent because we have a 1, it's x to the first, and a square root is with the 2. So I'm just going to erase this and put x to the 1/2. Now, since this is a denominator, we can make it negative. So I will show this next step. This will be 2 times the integral of x to the negative 1/2. So same rules apply. We can use the power rule. Let's add 1 to 1/2, or negative 1/2. So negative 1/2 plus 1 is going to be 1/2. And then we divide by 1/2. And then again, stay changes to a multiply, and we reciprocate. So this equals 2 times 2 over 1 times x to the 1/2. And then since our original was in a radical, we're just going to keep it as a radical. This is going to be 4 root x plus c. Part B, let's pull out the 3/2 outside. This is 1 over, and again, this is x to the 1/3. So if I rewrite this without a denominator, this would be x to the negative 1/3. Now again, to do this integral, I'm going to add 1 to the exponent, and then negative 1/3 plus 1 is going to be 2/3. So we're going to have x to the 2/3 divided by 2/3. Again, this stays. This division changes to a multiplication, and then we reciprocate. And then to finish this off, we're going to get 9 over 4. And then x to the 2/3. And again, that would be the cubed root of x squared, and always add your constant at the end. Next example, pull out your negative 1/3 outside. And this is going to be x to the 1/5 as a denominator. And if I rewrite it as a negative exponent, that's going to be x to the negative 1/5. So now we can use our power rule. So we're going to add 1 to negative 1/5, which should give us 4/5. And divide by that same 4/5. Always add your constant. You can do it at the very end. So again, stay. This division changes to a multiplication, and then reciprocate. And so we have negative 5 over 12. X to the 4/5. We're going to convert that back to a radical. So it's going to be the 5th root of x to the 4th. And then plus our c. Okay, so now getting into the trig. You can always use your tables as a reference. So the integral of sine is going to be negative cosine plus c. The integral of negative cosine, so let's move the negative outside and just do the integral of cosine of x, which we know that integral of cosine of x is sine of x plus c. So your answer is negative sine of x plus c. And then part C, take your negative outside, your negative 4. outside. And so now we know the integral of sine is negative cosine. And then if we multiply the negative 4 times the negative cosine, you get 4 cosine of x plus c. Okay, so these are just in properties. These are just the derivative properties again. And we've kind of already been doing them. So if you have a constant, you can always move it outside. If you have an integral of two different functions that are added, you can split the integral into two parts. Take the integral of this part plus or minus, it's a minus, the integral of this part. The integral of any constant is that constant with x as the variable. And then if you don't see anything there, think of it as a 1. The integral of 1 is 1x. And so now we are going to do example 7, which is a multiple part integral. Again, I am not going to rewrite it this way. It just takes too much. So we're just going to do the integral of each part. I will use arrows to point. Or maybe actually I'll do it one time. So let's break up this integral. And again, I don't think you should show this much work. So minus, we're going to move the 2 out here. The 4, we're going to move that one out there. So we're going to take the integral of 4 over x. And now each of these, again, should have dx. Actually, let me put those in. And so again, just to reiterate, I took the integral of each of these parts separately. This one was as is. Now the subtraction goes here, and now we're doing the integral of 2x squared. I moved the 2 outside of the integral, plus the integral of this function. And again, I just moved the 4 outside to get here, and then minus the integral of 1. Each of those should have a dx. Now this is, again, too much work to show. And then I'm just going to perform it. So if we do the integral of the first one, we're going to add 1 to x, so that makes x to the 4th divided by 4, minus, if we add 1 to the 2, that gives me x cubed, plus, now the integral of 1 over x is log of x, minus, and then the integral of 1 is just x, and then we always want to put our constant. And there you go, part B. And then that's the only time I'm going to do that. I'm not going to rewrite that a bunch of times. So if I want to do the integral here, I'm going to get 2. Actually, let's rewrite this to simplify it. So this will be 2 cosine of x dx minus 3 we're going to write outside. So 3 integral of 1 over x dx. And then finally, this function we're going to rewrite as 1/2. And we're going to move the 5 outside. And then again, we're going to write this as a negative 1/2. Okay, so taking each of these integrals separately, we're going to get 2. The integral of cosine is sine. Minus 3. The integral of 1 over x is log of x. Make sure you write the absolute value. Plus 5. And then if we add 1 to this, we're going to get 1/2. And then we're going to have to divide it by 1/2. And we always have our plus c at the very end. So to finish this off, this is going to be written as x to the 1/2, or the cube root, or excuse me, this is going to be written as the square root of x again. And then this is going to get multiplied as it's reciprocated, so this turns into a 10, square root of x, and then we get a plus c. And there you go, there is my integral. Like I said, this is long, so here's some strategies for integration. You always want to simplify before you integrate. It makes it so much easier. We don't really have a product rule or a quotient rule for integration. Sometimes that means distributing through, which is not really simplifying, but either simplify it if you can or distribute if you have two functions multiplied together. Always make sure, don't rush. Always check it to see if it can be turned into a better form. And just like I mentioned before, we don't have product or quotient rules for integration. If you're getting stuck, remember reverse the integral rules or the reverse of the derivative rules. So let's apply that to these. So this looks like a product rule to me because I have two functions that are multiplied. This is like f times g. But again, we don't have rules for that. So here, the strategy is to distribute. So we're going to get 3x squared. That right there is 12x, and then minus 1x, which gives us 11x. And then here gives us minus 4 dx. And then we just take the integral of each piece separately. Take the integral of 3x squared plus the integral of 11x minus the integral of 4. So if I add 1 to x, I get x cubed over 3. Those are going to cancel out and leave me with x cubed. Now I'm going to do the integral of 11x. There is a 1 here, so that's going to be x squared over 2, which we can leave that. That's 11 halves x squared minus the integral of 4 is just going to be 4x. And you always have your constant at the end. This one, so this looks like a nightmare. We have two things that are multiplied together, but this can be simplified. If you can recall, secant is equal to 1 over cosine. So if we simplified this first, we're going to get cosine squared of x times 1 over cosine of x dx. Now here we have one cosine cancel from the bottom. And this function is just simplifies to cosine of x dx. Now the integral of cosine is going to be sine of x plus your constant. This is similar to the question above it, A. It is squared. So if I distribute, I'm going to get 4x squared minus 6x minus another 6x for 12x total, and then plus 9. Now let's take each integral separately. This is going to be 4. So add on a 1 to the 2, so that's going to give me a 3 divided by 3. Subtract 12. And if you add a 1 onto the 1, you get x squared over 2. And then the 9, we're just going to get 9x. You always have your constant at the end. And if we simplify, we'll get 4/3 x cubed minus, these cancel out to a 6, 9x, and then plus c. Part D, again, we don't have quotient rules, but this numerator can factor to x plus 3, x minus 7. From here, this makes it super simple because we have the x plus 3 factors cancel. And so this just turns into the integral of x minus 7 dx. And so if I take the first part, that's going to be x squared over 2 minus 7x plus c. And that is your answer. This is x to the 1/2. And we're going to multiply it through. So when you multiply x times x, you're going to add the exponents together. Because again, if you recall, any bases that are the same and they're multiplied, you add exponents. That's a freshman level exponent rule. So when I multiply, I'm going to add exponents. I'm going to get 1/2 plus 2, which is 5 halves. So this is going to be the integral of x to the 5 halves minus 3x to the 1 half. And so for this integral, we're going to add 1 to 5 halves, which gives me 7 halves. So that's x to the 7 halves divided by 7 halves minus, then again, if you add 1 half plus 1, you're going to get 3 halves. So simplifying, we're going to move this outside and reciprocate. And then that's going to be the square root of x to the 7th minus 3 times 2/3. Because again, when you move this outside, it reciprocates. Times the square root of x cubed. And again, we always add the constant. And technically, these simplify. And so my final answer is going to be 2/7 times the square root of x to the 7th minus 2 times the square root of x cubed plus c. Okay, f, again, this looks like a product or a quotient rule to me. I am going to rewrite this with each base separately, because again, you can always split your fraction with each base. So a over r plus b over r plus c over r. But only with the denominator. And at the same time, I'm going to rewrite this as x to the 1 half. So we have x squared over x to the 1 half plus 4x over x to the 1 half minus 2 and x to the 1 half. And then again, these simplify using exponent rules. So the other exponent rule, when you have two bases that are the same, you can subtract the exponents off of each other. So this is going to simplify to x. This is going to be 2 minus a half, which is 1 1/2, or 3 halves, plus 4. And then again here, this is going to be 1 minus a half, which is just a half. And then we are going to leave, and the final one, we're going to rewrite this as x to the negative 1 half. So taking each of these integrals separately, we're going to add 1 to 3 halves to make it 5 halves. And add 1 to this, and then divide by 5 halves. So now add 1 to 1 half, which gives me 3 halves. And then again, we're going to add 1 to negative 1 half, which gives me 1 half. Divide that. And now it's just cleaning up. Again, anything you pull out of the fraction is going to be reciprocated. So here, when I multiply this outside, I'm going to get 8/3. This is going to switch back to the square root of x cubed. This will turn into minus 4 times the square root of x. And always add your plus c at the very end. So very similar to the previous problem. This one's actually a little simpler. So this is going to be 3. So if I take this x with the x to the 4th, that's going to be x cubed minus this x is going to cancel out with 1x from the x squared plus, and then we're going to write this as 3, and instead of writing it over x, we're going to write it as 3 times x to the negative 1 half. Now take the integrals separately. So the integral of x cubed, add 1 to the 3 to get 4, and divide by 4. Subtract. So we're going to add 1 to make this x cubed, always divide by 2, plus, oh, and actually we wanted to just kind of leave this as 1 over x because this integral is a log. Remember, you cannot take the integral of x to the negative 1 half. You can't use the power rule, it's a log. So this will be 3 log plus c. No really simplifying necessary there. Last example for this section. So again, we're going to simplify with each of these. So if I take x squared divided by 4x squared, I'm going to get the integral of 1/4 plus the x squared cancels out what one of these x is, and I get 3/4 times 1/x plus, and then again, there's no x's that cancel, so we're going to write this as 7/4. And instead of writing this as x to the negative 2, x divided by x squared, I'm going to write it as x to the negative 2. And we're going to take our integral now. So the integral of 1/4 of a constant is just that constant times x, plus we know the integral of 1/x is log, so this is going to be 3/4 log of x. And then here we're going to add 1, which gives me -1, and then divide it. Always add your constant at the end. So, I mean, if we wanted to simplify, we could. Let's just factor out a 1/4. Not necessary, but we'll do it anyway. So we have x plus 3 log of x plus, technically minus, because the minus comes out front. And we do have the 7, so we're going to put 7/x plus c.